Hey everyone, welcome back to the Science Enigma. Today, we're diving into one of the most mind-bending topics in science and theoretical physics, parallel universes. The idea that there might be multiple versions of reality running concurrently has fascinated scientists and science fiction enthusiasts alike. So, let's explore the question, are parallel universes real? To begin, what exactly are parallel universes? Well, in the realm of theoretical physics, the concept suggests the existence of multiple universes that coexist alongside our own. Each universe may have its own set of physical laws, constants, and even different versions of ourselves. There are several scientific theories that propose the existence of parallel universes. The multiverse theory, for example, suggests that our universe is just one of countless others, each with its own unique characteristics. String theory also plays a role, suggesting that there are additional dimensions beyond the ones we can perceive. Quantum mechanics, the fundamental theory governing the behavior of particles at the smallest scales, introduces the many worlds interpretation. This suggests that every time a quantum event occurs with multiple possible outcomes, the universe splits into different branches, each realizing one of those possibilities. Modern science can rule out some ideas, but not all of them. The possibility of the existence of parallel universes, which crucially depends on the definition of parallel, might be one of those ideas. A 2D thought experiment. Picture a two-dimensional world, like living on a flat plane, where inhabitants can only move east/west and north/south but are unable to move up or down. It's a simplified existence, akin to living on a sheet of paper. Now, let's introduce the idea of a three-dimensional universe, with our 2D world existing within it. Suppose that in this vast three-dimensional space, there are multiple two-dimensional universes stacked parallel to each other, with a tiny separation between them. Imagine these as sheets of paper, each representing a distinct two-dimensional universe. If such a scenario were to exist, we would have a stack of parallel universes, each existing independently yet sharing the same three-dimensional space. Now, let's consider the implications. One intriguing aspect is that the inhabitants of each 2D universe would perceive only their two dimensions. They could interact with their own universe but might be completely unaware of the neighboring universes stacked above and below. This scenario raises questions about what strange phenomena might arise. For instance, could there be interactions or influences between these parallel universes that we, as inhabitants of one universe, are oblivious to? It's essential to note that this thought experiment provides a conceptual framework for understanding the idea of parallel universes. But applying this concept to our three-dimensional reality introduces complexities beyond our full comprehension. The possibility of parallel universes, defined in this way, challenges our traditional understanding of space and raises exciting questions about the nature of reality. The ghost hypothesis. Now, let's delve into the ghost hypothesis and the intriguing idea that what some people perceive as ghosts might actually be individuals from a parallel dimension. The concept suggests that these entities are seen faintly because their images barely cross from their dimension into ours. Imagine creatures living on two adjacent sheets of paper, moving in tandem but separated by a minuscule gap in the third dimension. This idea has been proposed to explain the phenomenon of ghosts. However, science has something important to say about this hypothesis. Explanation of the inverse square law. We know from experiments that the intensity of light decreases with the square of the distance between the source and our eyes, known as the inverse square law. This law is a measure of the number of dimensions through which light can travel. Light spreads out through concentric spheres, and the surface area of a three-dimensional sphere is proportional to the square of the radius. The 2 in the 1/distance squared formula is equivalent to 1 less than the number of dimensions through which light can travel. If ghosts were individuals from a parallel dimension, light would need to travel through 4 dimensions instead of 3. The light intensity formula would then be 1/distance cubed. But measurements show that light intensity decreases as the distance squared, not cubed, indicating that light travels in only 3 spatial dimensions. This observation also ties into an astronomical mystery, the rotation of galaxies. For decades, astronomers have noted that galaxies rotate faster than expected based on the known laws of gravity and motion. Some have speculated that the excess rotation might be explained by the gravitational influence of mass from parallel worlds. If true, this would suggest that gravity could travel between parallel universes, affecting the observed mass of galaxies. However, just like the ghost hypothesis, this explanation can be disproven using the same logical framework. If gravity could travel between parallel worlds, its strength would decrease not as the square of the distance but as the cube of the distance. Yet, measurements show that gravity behaves in line with three-dimensional space, following the inverse square law. So, while the idea of ghosts and galaxies influenced by parallel dimensions sparks our imaginations, scientific principles, such as the inverse square law, provide valuable insights and constraints. Exploring these concepts not only deepens our understanding of the universe but also highlights the importance of critical thinking in the face of intriguing mysteries. So, where does that leave us on the matter of parallel universes? The precise measurements of light and gravity behavior seem to rule out the possibility of them traveling in more than 3 dimensions. However, does this definitively close the case on parallel worlds? Not entirely. The argument against parallel universes, as defined by interactions between matter and energy from one universe to another, hinges on the absence of such interactions in our observed data. If no interaction is allowed, we lack the data to conclusively rule out the conjecture. Yet, it's important to note that absence of evidence is not evidence of absence. Just as we lack data to suggest the existence of invisible pixies in your broom closet, we also lack data supporting the existence of parallel worlds in the defined sense. Consequently, we can tentatively conclude that, based on current scientific data, parallel universes, as individually interacting universes in higher dimensions, probably don't exist. However, it's crucial to recognize that there are other possible meanings to the phrase parallel worlds, and the logic applied here specifically addresses one interpretation. In alternative scenarios, the concept of parallel worlds may still hold different meanings and remain open to exploration. In the grand scheme of scientific inquiry, ruling out one conjecture is a step forward. The history of science is marked by the continuous refinement of theories, with discarded ideas paving the way for new and more accurate understandings. Stepping over the bodies of discarded theories is how science progresses. It's an ongoing journey of exploration, skepticism, and discovery. While we may not have a global statement on the existence of parallel universes, the pursuit of knowledge continues to push the boundaries of our understanding. What are your thoughts on these scientific considerations? Do you find these explanations compelling, or do you think there are still unexplored possibilities? Share your perspectives in the comments below, and let's keep the conversation going. And don't forget to like and subscribe for more explorations into the intersection of science and the unexplained. Until next time, keep questioning and stay curious. Thanks for joining us on this scientific journey.